Hey guys, welcome back to another episode of the Real Hacker Hours podcast. Today, this is basically just do my normal side project work. I just hit the record button before I do it. Today I'm going to continue looking at Postfix. Particularly what I want to do is, I know the last few days I spent looking at Postfix lookup tables, have a bit of understanding of how that functionality works. What I want to do is I want to start using effectively using some tooling, just like monitor and look at all of the various different API calls that are potentially vulnerable, such as like memcopy, strcpy, what have you. And one thing about Postfix is it has a lot of functions. Like here, let me show you. Okay, this isn't a good example. Okay, yeah. Postfix has its own type of data structure called Vstring, which it uses in a ton of instances, and it has its own implementation of things like Vstring, strcpy, and so on and so forth. What I want to understand is how those, and also originally when I was looking at Postfix, I thought like, oh, hey, it's probably imported in some library, but then I found, oh no, there's actual code in here that declares this. This is part of Postfix, not some external library that it imports. What I want to understand, I want to reverse that out and understand like this vstring strcpy. Is it like a normal strcpy where depending on what the arguments are, you can use it? It is a bug that you can use. So I'm going to be looking at that today. And let's see if I believe source util lsgrep vstring vstring, yeah, under util vstring.c is the file. Now, yeah, let's take a look here. Postfix source util. What is vstring.c? Cool. Here we are. So this is the, and also we in previous reversing work we have seen a lot of calls to like vstring alloc and that sort of thing. So let's take a look at vstring alloc, since from what I've seen so far, it's what I will actually like allocate and like spawn a new string. So void no vstring extend. Okay, so here's where it actually is. Returns a vstring pointer. Parameter is this length of the argument. Sees alloc. I should probably also take a look. Vstring.h is probably where it actually defines the structure of a vstring. Here we go, vstring.h. Let's take a look. Structure of a vstring. So vstring is just vbuff, it looks like we can. Okay, so the vstring buff, it looks like it's pretty much just a vbuff. Let's vbuff.h. Struct vbuff. Okay, I'm pretty sure this is what the actual structure is. Flags for the status. This is where the actual data is. Length of the buffer. Some sort of count, bytes left to read or write. The position within the string, which is currently being read or written to. Read buffer empty action. And it looks like these are just. Not sure what these are. Cool. So let's take a look at vstring alloc. What does it do? We see that since the vstring buff only has vbuff, it will actually just reference that for everything. So we see vbuff flag set equals 0, length equals 0, data is equal to the length malloc, using my malloc. I'm assuming that's a malloc. Actually, yeah, let's just take a look. We're fact checking everything right now. grep tech ir my malloc. This is called, no, it's probably other than util global. My malloc.c. Let's just make sure that this is doing what we expect it to. Okay. Message panic. Turn pointer. Malloc. Real pointer equals this. Checkout pointer. Memset. Okay, it's effectively just mallocing. There might be some things with checkout pointer that we could potentially do, but I'm not gonna spend too long looking at that. For now, I'm just gonna assume that vbuff, the data is set equal to a string malloc of that size. Let's see. And then, okay, this is a bit weird. It will set the length initially to 0 and then the length to whatever the length is. Get ready equals. Oh, it looks like these are instruction pointers which are stored. Get ready, put ready, space. Okay, cool. So effectively looking at this, vstring is a vbuff which is allocated, flags which is initialized to 0. This is a pointer to the actual data itself. The length which is initialized to whatever length was yeah, it was passed with the malloc count, which I don't see it being assigned a value here. Let me think. Looking at the other functions, I think it memsets is probably 0. Pointer isn't set, and these three are set to different functions. Cool. We know how strings are allocated. Vstring free. It frees, yeah, that's allocated. Yeah, it frees the data and it frees the actual greater vstring, but only if the pointer is valid. Okay, cool. So you have a good idea of how strings are allocated and freed. What I want to take a look at now is the functions like vstring, memcopy, memcat. Let's just see how many. Stir copy, stir and copy, stir cat, stir and cat, memcopy, memcat, memchar, insert, prepend, sprintf, sprintf append, and a few others. Cool. Let's start with stir copy since that's simple. Stir copy. And what I'm looking for right now on this, is there some check with the star copy so that this vstring right here can't get overflowed, or is there none? So we're looking through here. We see that source is just a normal char yeah, char pointer, and the string that's being appended to is a vstring. However, wow, okay, it's going to iterate through the string. Vstring. Looks like from here, yeah, it's effectively just iterating until the char pointer hits a null byte. It'll just continually append a byte to it, and then increment the pointer by one to move to the next character. Vstring terminate. We actually, first off, we see three different macros here: vstring reset, vstring add char, and vstring terminate. Haven't looked at these macros yet, but guessing based upon the fact that there is a count here, probably sets count equal to the beginning of it, adds a single character, and then no terminates wherever it is from. Let's see where these are. I'm guessing since their macros are probably defined in vstring.h. Define do actually vstring pointer equals the pointer that is current position is set equal to the beginning of the data, and the count is set equal to the length of the buffer. Cool. Okay. Add charge is vbuff put, so this calls a vbuff macro. Define. Okay, cool. So it checks first that count is greater than 0, decrements by 1, and vbuff put. Let's take a look at this. Get the feeling that this is some sort of like vbuff memory allocation, well, reallocation. Vbuff.c put ready. Handle write buffer full condition. What a vstring alloc put ready equals vstring buff put ready. So it calls it calls this pointer that's stored in the struct, which should be this vstring vstring extend. What is new length? Okay, it's calling my reallocate, which I'm assuming is just realloc. New length equals. Then it will terminate it. Wait, I just realized something. I need to check this right now, but I remember there's a ton of CTF challenges I did where what they would do is they would null terminate the byte by using increment. Oh no, this isn't the case because they're avid. Wait a second. BP length. Oh wait, no, I need to go to vstring alloc. Cool. Okay, no. What I was thinking of is I remember seeing a ton of CTF challenges where they would do just this. They would like allocate a length and then null terminate the length. However, the space being alloced is length plus 1, so we wouldn't potentially have a null overflow, or not null byte overflow. Since if it was just allocating length, then the index of length would be the next byte immediately preceding the chunk, but that's not the case here. And just to make sure, vbuff data is a char pointer. Yes, unsigned char, so it's only 1 byte. Okay, cool. So, looking at vstring extend. Let's see if it. Yeah, looking at here, I'm not seeing anything. Nope, don't want that. Too useful. Vstring alloc. Okay, so effectively, if it does see a potential overflow in it, count equals the length. And I just want to take another look at vbuff put. Vbuff put. Okay, yeah, I'm not seeing anything terribly useful that we could use here. Okay, so yeah, it looks like with a vstring star copy, if um if it does get to the point where it starts to overflow, it will automatically start like allocating more space in the destination buffer via realloc. So I don't think we could potentially use that for an overflow. Okay, stircat. Interesting. It doesn't call on vstring stir copy resets a string. Stircat does not. Might be able to do something with that. Link stircat. Vstring space memcopy. We see here that just directly calling memcopy. So vstring memcopy is just a wrapper for memcopy. However, it calls this vstring space. Let's take a look at that. Oh wait, this is a macro here. Debuff that space. What is the space function set to? Vstring buff space. This is probably just like a size check or some sort, and like reallocate if. Wait, what does need equal? Need if need equals length minus current count. What is CNT initialized to? CNT is not initialized to everything, so it's 0. If length minus 0. I'll have to see where vstring memcopy is called from. But at least we can say that with the stir copy, stir in copy, and stircat functions, judging from this effectively like memory check and subsequent resizing capability, we probably won't be able to do anything with those functions, even if it was configured in a way that a normal like stir copy would give us a bug. Memcopy, string space. Insert, what does this do? Locate by buffer. Okay. I've been going in for about 20 minutes. My dinner's ready, so I'm gonna head off right now. Thanks for watching.